Uh, we are climate developers. My name is Jaylene Salas. My family is from Mexico, but I was born and raised in Brooklyn, New York.
I'm Ebony Brown. I was born and raised in Brooklyn, New York.
My name is Toro. I was born and raised in Queens, New York.
My name is Melinda. My family's from Mexico, but I was born and raised in Yonkers, New York.
Hi, it's Jaylene again. Very excited to introduce our project with you, My Carbon Footprint. My Carbon Footprint was developed to offset the impacts of climate change through the collective actions of our users. The app allows the users to reduce their carbon footprints by examining how their diet, their method of transportation contribute to their overall footprint. And now I will pass it on to Louis to talk about our technologies.
Thank you. On this slide, you can see all the technologies that we use in the creation of our application. On the front end, we use React and Material to create and style our application. For data visualization, we use Chart.js and Tableau to build our carbon emission graphs and tables. On the back end, we use Node.js, Express, and Next to build our server-side routes so user can query our table and interact with our database. Now, we will be discussing the challenge we faced.
As product manager, one challenge arose when working with the highly complex Berkeley Cool Climate Calculator API, which required the user to input about 300 plus required parameters, which was very time consuming for both the user and us as developers to hard code for those specific parameters. And so given our time constraint, it wasn't ideal to use this as our main source. The solution for this was, however, to use the estimated version of the API that only required 3 parameters: the user's zip code, their income range, and their household size, and give them an estimated carbon footprint based on these 3 parameters. To the left is a code snippet of the data returned from the API that I use in order to calculate the user's total emissions. And using React charts to the right, we can see that the user is able to see their carbon footprint breakdown on how their food, their housing, their method of transportation, goods and services contribute to their overall carbon footprint based on the average users with the same demographics. And now I will pass it on to Ebony.
Okay, I'm Ebony. I was a Scrum Master, and a couple of challenges that I faced was allowing our users to safely register on our platform and visualizing user input stored in our database. I use JWT and bcrypt so the users can securely sign up for our application and not worry about their data being exposed. And I use Material UI, Chart.js, and Mapbox for data visualization so that there were multiple representations of their daily input. Oh, and I'm having internet issues, so I can't see the slide changing. I'm going to talk like it changed. So on the left, there should be a code snippet showing the form the user data will take after it's parsed, and this will be passed to our table and graph components. On the right is a test for
I think she cut out.
I think I'm back. Okay, so I don't know where I cut out, but that's fine. On the right is a test for a future feature I thought of to improve our user experience during the transportation quiz. The user would no longer have to remember or calculate the miles they traveled and just input the location so we can take care of the rest. And now I'll pass it off to Melinda.
Hi, everyone. So I was one of the engineers on the team working primarily on the front end. The main challenge I faced was finding an API or a library I could use to make a customized carbon footprint quiz. Instead of working with the inflexible Cool Climate API we had originally found, I decided to use a different resource. Using the carbon footprint library, I was able to create a quiz which would calculate a person's carbon footprint based on their food consumption and transportation habits. In order for this library to work for our purposes, I had to supplement it with additional code to account for the conversions we wanted. Next slide. So on here you can see how I calculated the CO2 emissions from a person's food servings. The first photo shows the library I worked with and the property I added named emissions per serving, which holds the amount of CO2 emitted per food serving. The second photo shows how I calculated the total emissions according to the food items and the number of servings a user inputted. Now I'll pass it to Lewis.
Thank you, Melinda. So as an engineer, one of the problems that we faced was that we need to find a quick, easy, and flexible way to store our user data into our database. So as a solution, we thought about using Next. Next gave us the functionality to create and alter our user, food, and transportation table using the query builders. Turn back the clock on our database with migration and populate our table with initial user and entry with seeding. As a result, whenever changes had to be made to our database, we could quickly and easily use migration to alter our tables. Next slide. Thanks. Here is an example of Next seeding. We are extracting our food array object and inserting each object into our food table as an entry. First, we built an array to hold all the entries that we will be inserting into our food table. Next, we had to create an entry from each incoming object, such that we use the username from the extractor file to access the user ID from the user table so that we can correctly insert the user ID as part as a food entry. And lastly, we return the promise to be inserted into our food table. I will now be passing the spotlight over to Jaylene so she can showcase our demo.
Thank you, Lewis. So when a user is introduced to our app, they're presented with the landing page where they get a small introduction about what exactly is a carbon footprint. If they scroll down, they could also see some small animations that explain the purpose of our app along with our mission statement and some brief information about our team. But if we scroll back up, the user can now decide whether they want to take an in-depth analysis, which is just a series of quizzes to get an accurate carbon footprint, or they can take the general assessment to get an estimated carbon footprint. For this example, I will be logging in as our user, Bill. Takes a while. So when a user logs in, they are redirected to their home page that shows their total current emissions, and then they're also presented with their set emission goals that they wish to achieve. And then here, we can also see how Bill compares to the average person within his zip code. To the left, we can also see the leaderboard. So the leaderboard is based off our users, and we keep track on who has the lowest carbon footprint so far. And then to the right, we can see a list of pledges that our users can take to offset their carbon footprint. So for this example, let's say Bill wishes to carpool 2 days a week. And if he hits pledge, we could see how much he offsetted his footprints. And if he actually goes through with this and completes it, he is then rewarded with confetti. But just as an example, Bill wants to log in and see how much his lunch emitted. So we're going to go to our quizzes. And for this, he also wants to input his transportation for the day. So let's say for lunch, he had some chicken, vegetables, and let's put potatoes. Now he has to enter how many servings did he eat. So let's say he ate 2 servings of chicken, 1 serving of potato, and 2 servings of vegetables. Now he has to input his method of transportation. So Bill today took the bus. And how many miles did Bill take? Let's say Bill took about 4 miles or 5 miles to buy some groceries. When he hits submit, he is presented with the breakdown of his food entries along with a graph that shows the breakdown of his carbon footprint for this specific meal alone. Okay, before Bill decides to log off, he wants to see how the rest of the United States is doing. So he heads over into our carbon map, which is just a map of the United States broken down by zip codes, where he could see how every zip code's carbon emission is doing so far. So here's the map, and Bill can just hover over and see how every zip code is doing. So here's just like an example of like the zip code, and he could just go through this on his own. So this is the end of our app, but if we have more time, one of the one of the main features we wanted to add was to add more different categories, such as adding an electricity sections or a product and service section, and have our users analyze how those certain lifestyle choices affect their carbon footprint. Thank you so much.
Huge round of applause for my carbon footprint. I think we all agree that we could probably use that app and would probably change some of my day-to-day lifestyle decisions if I had it.